what? When I say that omega equals to what? Omega equals to theta upon time. So this is the
Yeah.
formula when we are stopping the bob at any time t in between. The bob is not yet covered the entire distance.
Yeah.
So the bob is at some point here, covering some theta in some time t. But the
Yeah.
moment it goes up and up and up and covers the entire round, but the bob, we are considering the bob to be moving with a constant speed, constant omega, constant angular speed. So when the
Yes.
bob is actually moving with a constant angular speed, what do you think would mean? What that mean? That would mean that it is 2 pi over time. And when it is 2 pi over time, just we can also separately write that down also, because here we are considering the full round angle
Yeah.
over the full time period. And here we are covering any angle at any time t. Yes or no? So
Yes.
omega shall be what? Omega shall be 2 pi over t. And what is this? Can I say 2 pi into 1 over t? And what is 1
Yeah.
over t? That is frequency. We just learned 1 over
Yes.
t is frequency. So omega shall be 2 pi f. So sometimes,
Yes.
sometimes if we have to calculate the time period, right? So from here,
Yeah.
if you understand what we would write it down. From here, we would say that time period shall be omega over, I would write down 2 pi over omega. Time period shall be 2 pi over omega. Yes or no?
Yes.
And here I can write down frequency shall be omega over 2 pi. Understood or not?
Yes.
So this is also one of the parameters that we can write it down. I hope you're understanding.
Yes.
Right? So this is very, very
Yeah.
important part, that how it is actually coming about. So omega shall be 2 pi by t. 1 by t shall be frequency. Frequency is also omega upon 2 pi. One of the ways of writing it down.
Yeah.
Understood or not?
Yes.
So
Understood.
when I write down this x is equals to, when I write it down, this x is equals to a sine omega t. Can I also write it down this way? A sine omega. Omega I am substituting with what? Omega I am writing down with 2 pi by capital T into small t. So what is small t?
Yeah.
Small t is any time. Why am I saying this? This is the equation. Sometimes the question gives you directly omega. So you use this equation, the top one. But sometimes the question gives me capital total time, and the question gives me some any other time. So then you use x,
Yeah.
this formula. I hope you're understanding,
Yeah.
right? So this is the concept.
Yeah.
This is the concept. Any doubts in this part?
No.
Right? So this is how we actually do the derivations part. So next class we'll be doing certain more numericals, and because I have a class right now,